And the last time that we discussed how to use R, and this time that I focus on basically vectors. So the biggest difference between usual calculator and R is that R can handle the vectors, matrices, and even higher dimensional arrays. So today I will quickly discuss other features on, maybe we haven't, yeah, we discussed other features on vectors in R. And hopefully we will have a few minutes for exercises. And I will use the breakout sessions if I have time for exercises. Okay, I will share the screen. I will check the attendance later. Okay, so last time that we studied how to generate vectors. So I hope you're seeing screen. And how to define a vector in R. You can use the C to declare a vector. For example, C, 1, 2, 4, 8. So this makes a vector with 4 elements. Maybe there you can define vector with more elements, then you can see the results in this way. And I think that is what we have done. And last time, we also discussed how to calculate some basic quantities, such as summation or mean or variance or standard deviations. And I would like to mention that if we combine two vectors in R, that becomes a vector. So it's kind of not logical because the set of two vectors are not really one vector, but in R, it works in that way. For example, we have vector X here. Maybe X is C1 to 3, 1 to 4, 8, and Y is maybe C16 and 32. And if we put X and Y, then it becomes another vector with 6 elements. Actually, today's quiz may use this knowledge, so I would like to discuss it. And yeah, I have already put one example of sequence, but if you want to make a sequence of, for example, 1 to 100, then you can type just one colon 100. Then this becomes a vector with these 100 elements. Yeah, you can use it from this function from, for example, 5 to 10. Then you can get the sequence of 5 to 10. This is a little bit vague. So this makes the sequence from -5 to 10. But if you want to make a sequence of -5 to -10, probably you have to do that. So if you are unsure about the situation, I recommend you to put some parentheses. For example, -5 to 10. This is a kind of vague statement, but if we put parentheses -5 to 10, it's clear that this is a sequence from -5 to +10. Yeah, so sequence can be in a different order from 4 to -3. You can make this sequence. Also, if you want to make a sequence from, for example, 0 to 1 with increment of 0.1, you can do this by making this 0 to 10. Sequence of 0 to 10 is 0, 1, 2, 3, 4, up to 10. But if you multiply by 0.1, you can make this sequence. So this is sometimes useful. Also, we have sequence SEQ function. So 0 to 10, length 6, then you can get the sequence of 0 to 10 with length 6. So that means we have 5 intervals. So 5 intervals, and the distance between the end point and the start point is 10. So 10 divided by 5 is 2. So increment becomes 2. So this is a vector with 6 elements, starting with 0, ending with 10, and the length 6. And also you can specify increment rather than length. This is maybe more natural. So this becomes 0, 3, 6, 9, 12. Also, sometimes we want to repeat some observations. For example, 1, 2, 3 many times up to 10th elements. Then you can make a vector in this way. If you exactly repeat 1, 2, 3 for 3 times, then you can do this. Yeah, of course, you can every time type like this to make a sequence, but this isn't very convenient if we have many observations. So we can use seq function and the repeat function to generate it. Do you have any questions so far? Okay, so now that we do some more functions on vectors. Suppose A's are vector with the 100 elements. If you type head of A, then you can see just the first few elements. Usually the 6 is default, the 6 elements of A. And you can calculate maximum of A by max parenthesis A, and the minimum of A by this, and the median of A in this. So yeah, so median is the value at which the half of the elements are below that value and half of the elements are above. So that is somewhere between 50 and 51, but the R returns the center of the value, so 50.5. Also, we have a quantile function of A. For example, that we want to get the 25th percentile. That means 25% of observations are below that point. That is 25.75. So this number should be somewhere between 25 and 26. And R have the several options to calculate this. And this specification, the default specification, returns 25.75. Yeah, so I don't want to spend too much time to discuss the details, but there are many options. I think 7 options to get exact number of quantile. So this is the help of quantile function. And we have several different options. Oh, maybe not, maybe just the type 1, type 2, type 3. Type 4, type 5, type 6, yeah, actually type 9. So we have 9 different definitions to define quantile. So that number should be between 25 and 26, but theoretically, some people believe maybe just the in between. Yeah, some people believe that that is 25.5. Some people believe 25.75. So we have several options. But anyway, so the difference is small, especially if we have many observations. And quantile, A maybe 0.75, this returns the third quartile or 75 percentile of the observations. So this returns 75.25. And the 5num function returns the 5 numbers. So first one is minimum, and the second one is basically 25th percentile. This has slightly different definition from this quantile function, but basically this is 25th percentile or first quartile. And the third one is median. And the fourth one is the third quartile or 75th percentile. And the last one is maximum. So it returns 5 numbers at once. So some functions return multiple numbers. 5num function returns 5 numbers. I think there is a quiz about this for today. Do you have any questions so far? Yeah, and I have already done that, but if you don't really know exact definition of a function, you can type the help of quantile. Then you can get answer for this. So help is in a different window. Sorry, where's that? Help. Yeah, help is another window which explains the function of R. Sometimes this help does not help much to understand how to use it. It's a little bit abstract and not user-friendly way of explaining functions. So yeah, you can search on the Google what kind of information is available. Yeah, another way is like the help. Another way to search our help is the help.search function. Then you can put some keyword, how to calculate average. Then it returns something. Yeah, I think it doesn't help much. So the mean function calculates average, but it does not really return the mean function. So probably it's better to use just Google to see how to calculate average of numbers. Yeah, so Google, there's some keywords, or you can use help function to identify the meaning of the function. Okay, so the next one, some data manipulation. So suppose we have the vector A. Vector A, it consists of maybe 5 elements like this. And how to order these observations? We can use the sort function. Then you can order it. Maybe if you want to use this, maybe you can name this as like B, and then you can use B. Yeah. We have, if you want to sort in decreasing order, then we have several ways. The one is the sort A function with decreasing option. Decreasing is equal to true. Then you can get this A in decreasing order. And another way is just sort function and the reverse function. Then you can get the same answer. So the REB, the reverse the relationship. So maybe rev A is also possible. Originally, the vector A is 2011, 9 to 12, but the rev A is in a different order, in an opposite order. And then I want to discuss the rank function. So again, A is this, and rank of A returns this. So this means the 20 is 5th smallest observation, and 11 is the 3rd smallest observation, 9 is 2nd smallest, 2 is the smallest, and the 12 is 4th smallest observation. So rank function returns the rank of these observations. Another similar function is order function. Order function of A returns this. So this means the 4th observation is smallest. The 4th observation of A is 2. So 2 is smallest. And the 3rd observation is 2nd smallest. So the 3rd observation is 9. So this is 2nd smallest. And the 2nd observation is 3rd smallest. Actually, 11 is the 2nd smallest. And 11 is 3rd smallest, and so on. So for example, if you want to get the 2nd smallest observation in A, you can get the 2nd observation. So the order A of 2, so this returns 3. So this means the 2nd smallest observation is the 3rd place, 3rd elements of A. So if you put this in A, this is equal to A of 3. So this is 9. So you can get the 2nd smallest observation with just one line of our code. Of course, if we only have 5 observations, it's obvious. But if we have hundreds of observations, that this function may be useful. Sometimes you want to get the fifth smallest observations out of 100 observations. Any questions?
I guess, when will we use this function? Like, do you have like an example when like the order function would be pretty important?
Yeah, order function, actually the most important use is this. So the how to identify like 10 smallest observation and so on. Yeah. So most of the time I use order function within this, the object. So we identify like fifth smallest, tenth of smallest observations. Yeah, and yes. And the to be exact, when we have to order it, for example, maybe x is okay, so a is here, okay, and b is another vector, maybe just randomly. Okay, randomly this. And for example, plot AB, then you can get this kind of plot. Maybe 50 is too large. But if we want to make the line graph, usually it does not work well as when just if we type line graph, because it becomes this. Usually you want to connect these observations in increasing order of A, right? So then if we want to make the line graph, then you can put this, then you can make a line graph. For example, order of A can be used for this purpose.
Gotcha, thank you.
Yeah, it's a very good question. Okay, so data manipulation, number 2. Sometimes we want to take the difference from the previous observation. So A is this vector, but we want to, so the difference from the last time is important. The 11 minus 20 and 9 minus 11, 2 minus 9. So these are important sometimes. For example, this is the number of customers and you are running a business, then you want to see how many more customers you get during the last quarter. Then the change from the last time is important. Then, of course, you can do it manually, like the A2 minus A1 and A3 minus A2 and so on. But it's so it takes so much time. So we want to do it automatically. Then you can do the difference of A. Then you can see 11 minus 12 is negative 9, 9 minus 11 is negative 2, and so on. 12 minus 2 is 10. So original vector is have 5 elements, and the def of A have 4 elements. Yeah. Yeah, there are many other ways to do this. For example, maybe I prefer this notation more. Second observation minus 1, third observation minus second, and fourth observation minus third, and so on. So there are several ways, but the def of A sometimes helps. And range of A, this returns range of A. So 2 is smallest and 20 is largest. So minimum and maximum. So this is useful, for example, to specify the range for plot. So sometimes we have to specify the range for Y. So in this case, we only have the one line. So R automatically adjust the minimum into the range of Y-axis to minimum observation to maximum observation. But if we want to create maybe 3 line graphs in the same window, then you have to exactly specify what's the range for that sometimes. So range can be used for that purpose. And we have studied the summation function, but also we have the product function. Product of A is this. So this is 20 times 11 times 9 times 2 times 12. Yeah. Any questions so far? Okay, and some more calculations. So from now on, we discuss a function for two vectors. So suppose we have two vectors. First vector is this. Suppose that this is the maybe the midterm 1 scores for 5 students. And also that we have the midterm 2 scores. So the first students get 10 in midterm 1 and 20 in the midterm 2. And the third one, fourth one, and this is the maybe midterm 2 scores for the same. And mid1 and mid2. So these are two vectors. And the one function, the Pmax of mid1, mid2. So this returns the component-wise maximum. So best scores for each student. So first student, the midterm 2, he or she did better in midterm 2, so it returns 20. And second, the 50 and 80, maximum is 80. So this, I don't know if we have 3 vectors, it may work, may not work. Yeah, so suppose this one, everyone gets 90, for example. Tmax mid 3, I don't know. Yeah, it works. Yeah. Yeah. And P minimum also works in the same way. So P min. Smallest score for each student. You can make a scatter plot of mid1 and mid2 that is here. Maybe it's a little small, so maybe 5 times larger. So we have some positive trend. So correlation should be positive. We will study correlation from now on, but we have positive relationship between midterm 1 and midterm 2. So you can calculate correlation of midterm 1 and midterm 2 by COR function. So first input is one vector and second input is another vector. So-called Pearson's correlation coefficient, 0.7. Yep. And correlation, maybe I have to switch to slides to explain what is correlation. 50, 30, chapter 1. Yeah, so correlation coefficient is defined in this way. So suppose that we have n pairs of observations. Actually, last time in R, we have to define vectors first. So vector of x1 to xn and vector of y1 to yn. But mathematically speaking, we have the n pairs of observations. In the previous example, 5 pairs of observations. X is midterm 1 score, y is midterm 2 scores. And the correlation coefficient is defined by S sub xy over S sub x, S sub y. S sub x is standard deviation of x, S sub y is standard deviation of y. So we standardize by the scale of x and the scale of y. And what is S sub xy? S sub xy is so-called the covariance, the sample covariance. So that is this. So this is a kind of similar to variance, sample variance. If you replace the second factor to xi minus x bar, then this is exactly the definition of the variance of X. So just we replace the one factor by the other vector. So that is the covariance. So actually the reason that the variance, sample variance is sum of squares is that the we can generalize this into the concept of covariance. If you replace the one factor to another vector, then actually we can define covariance. And here X bar is the mean of X and Y bar is mean of Y. So correlation coefficient has this property. So the correlation coefficient is usually denoted as R for sample case. And the R is always between -1 and +1. So you can prove it by Schwarz inequality if you would like. And when R is positive, then X and Y have positive linear relationship. That means when X is larger, then the corresponding Y value is likely to be larger. And R is negative, X and Y have negative linear relationship. That means that if X is larger, Y is likely to be smaller. And R is equal to 0 means X and Y does not have linear relationship. So X increase in X does not imply increase in Y and does not imply increase in Y. So these are some examples. So for example, the second one, you can see so we don't have X-axis and Y-axis, but the horizontal axis is X and vertical is Y. When X is larger, the Y value tends to be larger. We have positive trend line. So we have positive correlation coefficient. And if relationship is stronger, then correlation is larger in absolute value. You can see if we compare this 0.8 and the 0.4, for 0.4, even though the trend line is almost the same, the relationship is bigger than this one. So you can see in this graph, even if X is larger, more often Y gets smaller. So here we have stronger relationship. And if we have perfect relationship, that means increase in X always means increase in Y, then correlation is Y, 1. And negative case, we have negative trend line here, here, and here. And the slope does not matter for correlation coefficient. As long as the relationship is perfect, even if slope is smaller, the correlation coefficient is 1. And here you can see Y does not have any variability. So that means standard deviation of Y is 0. And standard deviation of Y is in the denominator of the definition of correlation coefficient. So that means we cannot define correlation coefficients. So that's why we don't have any number here, cannot be defined. -1 here. And the lower graphs, so these have all correlation coefficient of 0, even though X and Y are related. So in any of these cases, we don't have any positive trend line or negative trend line. We have relationship between X and Y, but we don't have any linear relationship between X and Y. So we have some nonlinear pattern. Maybe this is also another nonlinear pattern. Yeah, this is also. And last one, maybe clusters. Yeah, so these have correlation coefficient 0. So that means correlation coefficient is non-zero. We have some pattern, but the correlation coefficient of 0 does not mean it does not have any pattern. Even some pattern are there, still we have correlation coefficient 0 sometimes. Any questions so far? Yeah, I think we have to put some credits here. So this is from Wikipedia. And this is the reason why correlation coefficient identifies linear relationship. So think about the 3 cases, this one, and this one, and this one. The first one, we have positive trend line, and correlation coefficient becomes positive. Why? Because the correlation coefficient is basically summation of this term. So xi minus x bar times yi minus y bar. Xi minus x bar is basically the distance from x bar, the signed distance from x bar. So the basically the baseline is x bar, and we see the difference between x value and x bar. And yi minus y bar, the same thing. And if positive relationship between x and y, actually most observations are in this region 1 and region 3. And in region 1, actually both factors are positive. So you can see xi, x value is larger than x bar, and the yi is larger than y bar. So positive. And region 3, the xi minus x bar and yi minus y bar are both negative. You can see the xi is smaller than x bar, yi is smaller than y bar. And yeah, so that means we take summation of this, but the most of the elements are positive. So that means the summation is likely to be positive. Yeah, and on the other hand, if we have negative relationship between x and y, most observations are in region 2 or region 4. In region 2, actually the first factor of this term is negative because xi is smaller than x bar. But the yi is larger than y bar because yi is above y bar. So that means negative times positive. So the product is negative. So this product is negative in region 2. With the same reason, in region 4, we have negative value for this term. So most of the observations are in region 2 and region 4 for negative relationship case. So that's why the correlation coefficient becomes negative. And the last one, if we don't have any linear pattern, most likely the observations are distributed equally over the 4 regions. So we expect that the correlation coefficient is around 0. Yeah. Any questions so far? Yeah. So this is the definition of correlation coefficient. So correlation coefficient is calculated by just COR function. But if we know the definition of this COR, the correlation coefficient, then we can actually calculate it in a different way. Yeah, so yeah, there are several ways, but you can define the correlation between x and y. So suppose that the x is midterm 1 score, y is midterm 2 score, then you can calculate this by 1 over n minus 1. So we have 5 observations. So this times summation of the midterm 1 score minus mean of midterm 1 score times, maybe I have to put it in a parenthesis. So parenthesis, midterm 1, and times the midterm 2 minus the midterm 2 score, mean of midterm 2 score, and this. Then this, yeah, then we get the S sub xy. This is the 700, maybe. And the standard deviation of y, standard deviation of x, that can be obtained in the same way. Standard deviation of x, maybe that you can do it in the same way. Maybe we have to take the square root of this, square root of, maybe just we omit this as this, and we have to take just square, so like this.
You need a parenthesis.
Yeah, thank you. And y as well. Then S sub x, S sub y are these, and actually the same. And the S sub xy divided by S sub x times S sub y. Then we get 0.7. Any questions? Yeah, maybe more general argument, you can replace 5 by length of midterm 1. So this length. Yeah, so this returns 5. So in general, you can translate into this. Yeah, sometimes the finding an R function takes more time than coding everything by yourself. Okay, so next I would like to discuss a function which returns the many output. So one example is this t-test. Maybe you have studied t-test before, but the yeah, so t-test. So midterm 1 and midterm 2 are in the our session, and we can use the t.test function to see the difference in mean midterm 1 score and mean midterm 2 score. So mean of these scores are 50 and 60. So maybe midterm 2 have higher score, but only 5 students. So maybe we cannot really say midterm 2 is easier than midterm 1. In such a case, we want to get the paired t-test. So t.test, we take the difference between midterm 1 and midterm 2. So t.test only takes one input in this case, but it returns complicated object, which includes many numbers such as t-statistic or degrees of freedom, p-value, and maybe confidence interval, and the mean of difference, and so on. Yeah, so this means that this test statistic follows t-distribution with df4, degrees of freedom 4. And t-statistic is negative 0.91. And the p-value is 0.413. And the hypothesis that the two exams have the same population mean is not rejected in this case because the p-value is not less than some threshold value. So usually the p-value is less than 0.05 or some specified threshold that we regard the null hypothesis of two exams have the same population mean is rejected. So in this case, there is no evidence that the midterm 1 score is significantly different from the midterm 2 score. So usually it's hard to make a significant result with 5 observations. Yeah, we will cover this later again, but just I want to explain that some function have multiple outputs. Okay, so next one, I think this is important in terms of coding. Character vectors. Maybe this slide. Okay, so I'm doing slide 34, and this is not too difficult, but the maybe next slide is more complicated. So some vectors consist of character strings. So far we studied just only numeric vectors, but sometimes vector indicate the names of 3 people or something. So in such a case, we have to put the information in this quotation symbol. And then in this way, you can put the 3-dimensional vector of characters. So baby name is vector with 3 elements, Andy and Brian and Casey. You can access the element by this way. Yeah, I think this is fine. This is probably not difficult, but the next slide is a little bit complicated. So factor vectors also. So sometimes we have some vectors such as male, female. This is the gender of 5 people in the data set. So this is a character vector. Male, female, unknown. But sometimes we want to analyze this based on gender. For example, we have another vector for height, and we want to explain the height by gender. So in such a case, we want R to recognize the first and the third elements are the same, and the second and the fourth elements are the same. So R, at this point, R recognize these 5 elements as just a sequence of letters, and it does not recognize the first and the third one are the same. So to make R, to recognize this, categories, that we have to use the as factor function. So I write this as GF, the G as factor. Then, so this vector becomes this. So on screen, the difference is at first, we don't have any quotation symbol here. And also R returns this vector have 3 levels, female and male and unknown. So actually this is the alphabetical order. So if we use the, if you want to change the order, that you can change, you can specify this levels option. So for example, GF is as factor levels. Male, female, unknown. Oh, sorry. Levels function. As factor G levels male. Maybe we have to define factor. Maybe slightly different, maybe factor, maybe. Then you can change the order of these levels. Okay, maybe, yeah, okay, so we define this as GF. Then, yeah, now the R recognizes that there are 3 levels for this vector. And we want to change this as numeric sometimes. Then it returns 1, 2, 1, 2, 3. So male is the first category, female is the second category, and unknown is the third category, and so on. Yeah, so one confusing fact is if we transform this into character vector again, so this just becomes 1, 2, 1, 2, 3 in quotation symbols. Because at this point, R knows that we have names for these 3 categories. But once you make it numeric, so these, the information, so that the spells are lost, and that we can only get the 1, 2, 1, 2, 3. mathematically this one and this one have the same structure, but we lose the information of these character sequences. Yeah. But still, sometimes we want to make it numeric. For example, you wanna put some information on male in some, first column of some matrix, or the information for female in the second column of some matrix, and so on. So in such a case, sometimes we want to make it numeric, but once you make it numeric, the character information is lost. Do you have any questions? Okay, so if not, I would like to do some exercises. So I will set up the breakup room and do exercise. Oh, and the exercise is available on the website. So you can download from the Canvas. I will show it to you. It's just one exercise. Actually, the 2 questions, but the 2 has not been done yet. So we have 6 countries, and we have data for unemployment rate and inflation rate for these 6 countries, A, B, C, D, E, F. And you can see that from this information, the countries with higher unemployment rate have lower inflation rate, like countries A, B, and E. And countries with lower unemployment rate, like C and D, have higher inflation rate relatively. Not very clear relationship, but so based on this data, I would like to ask several questions. So at first, based on X and Y, you can calculate. I would like you to calculate some linear combination of X and Y. So unemployment and the inflation are both miserable. So the X plus Y, or some kind of linear combination, is called the measure of misery in economics. So I would like you to calculate this for 6 countries at once using vector operations. Then it asks mean and the standard deviation of countries and so on. Okay, I will make a breakup room and want you to discuss each other with your classmates. And maybe I have to, I have to stop sharing to set up breakup out rooms. How many students here? 1, 2, 3, 4, 5, 25. 25, so maybe 6, 7, maybe 7 rooms I will set up. So then I would like you to discuss each other.
It's for grade.
I do not grade, but yeah, sorry about that. Yeah, okay, I will open the room and you can discuss for maybe 10 minutes first.
Oh, it's not graded.
Not graded, yeah. Maybe, yeah, 10 minutes first. Okay, so I enjoy your conversation.
What does the order do again? I have a question. What does the order do again? You know the order function. The order. What does it do? Does it sort the element? I forgot what it does. What does it do?
You're on mute, Professor.
Professor, I think you're muted.
Sorry, the Kevin, are you asking a question about order function?
Yeah,
Okay.
What does it do? What does it do?
What's the meaning of order function? Okay, so yeah, order function. Yeah, so it returns. Okay, so a. So order function returns these numbers. So this means the fourth observation of A is smallest. Okay, so the first one.
I get now. It does that.
Got
I get
it?
it now. Yeah, I get it now.
Thank you. Okay, so now that we discuss the answers for the question quickly, and so the first question is so sorry, we have the exercise 1. We have the unemployment rate X. So X is these numbers 7.9 and 11.1, 2.9, 5, and the 9.8 and the 8.5. Okay, and Y is 1.5 and 0.3, 3.5, and the 2.1 and 2 and 4. Okay, then we want to calculate the misery index for this. So that is X plus 2Y. So you have to be careful that you have to always put the asterisk sign here. So X plus 2Y. So this is the measure of misery. So 10.9, you can see the 7.9 plus 2 times 1.5 is 10.9, and so on. So these are the measure of misery for 6 countries. And calculate the mean and the standard deviation. Okay, so question B. Calculate the mean and the standard deviation of X and Y. So mean of X and standard deviation of X. So yeah, you can put it in the same. Sorry, this is capital X. And the mean of Y and the standard deviation of Y. So if you want to get the answer in one line, you can get. So this is the mean unemployment rate, standard deviation of unemployment rate, and the mean inflation rate and the standard deviation of inflation rate. And C, we want to get standard deviation without using SD and variable variance function. Okay, so we focus on just unemployment rate X, and the X sub I minus X bar, that is at first the quantity we want to get. And actually we can get this by X minus mean of X. Then so X is a vector, mean of X is just a scalar, but you can subtract mean of X from each element of X. So that is X minus mean of X. So if you do this and take square, then take summation and divide it by length minus 1, so that is the length of X minus 1, then you can get the variance of X. So this is variance. So standard deviation is the square root of variance. So the square root.
It's sample variance, not population variance. It's sample variance.
Sample variance. Yeah. So we are talking about data. So variance for the data. So this is the sample variance. So this is sample standard deviation. So this is 3.09. And you can do the same way to get the standard deviation of Y. So yeah, actually you can push the up arrow to get the previous code, so that you can just generate this and you can change this into Y, then you can get standard deviation of Y. So you can get this and this the same. And correlation coefficient, if we are allowed to use COR function, you can directly calculate this. You can get the plot of x and y in this way, and you can get, okay, so negative 0.55. So we should have negative correlation between these two. And yeah, we have some negative correlation between observations. Maybe not very strong relationship, but still the negative correlation. Okay, sorry, I would like to check the attendance, and I have already checked attendance, but just I want to make sure. The Karsten not here, Christine or Karsten, Dalvar not here, and Alexander, I think Alexander is here. Alexander, not here.
Yeah, I'm here.
Oh yeah, okay. And the Caitlin Miasgar, not here. And I think Jason is here. And Tamika not here. Tanganyika Washington, not here. And Assad Atkins, not here. Andrea Kak, Nicholas Kostakis, not here. Okay, great. And there is one request from one of your classmates, and he has some disability, and he wants to have our classmate to study the contents together. Sometimes probably he missed something what I said. Is anyone interested in working with the student, or at least are you willing to do that? Anyone? No. Okay, so I will email this information again. So, and do you have any questions about today's material?
No.
Go ahead. No? Okay.
I was just saying no. So you had an
Okay.
answer.
Okay, great. Okay, so that's it for today, and see you next. Oh, sorry, next Tuesday. Yeah, I will upload the quizzes for today later. Okay, see you.
Have a good
Are we
week.
are we doing next Tuesday before class?
I will give you quizzes just after the class. Yeah, maybe
Well, I mean,
within a few hours.
are we doing like are we due for grading? Are we doing before class next Tuesday?
What the grade quizzes or?
Yeah, I mean, you gotta do it before it's due. So what?
But
Yeah,
when
do
is the
it.
due date for
Yeah,
quizzes?
that.
Quizzes. Probably no. Today is Thursday, so the 3 business day is Friday, Monday, Tuesday. So I will make the quiz due on Tuesday at 11:55 p.m.
Yeah, I get it.
Thank you.